Good evening, students. So today's lecture is purely on our the network layer, that is layer number 3. So before starting today's lecture, we will see what we are covered in our last lecture, right? So we have seen the network model and its functionalities, right? The total number of layers are 7, to from the physical to your application layer, and what are the functionality of each of the layer up to the upper layers we are seen in last lecture, right? So after that we again seen the then what do you mean by the TCP IP models are there, then what are the similarities in between the OSI and the TCP IP model, right? Then what are the different functionalities of the upper layers, that is from your transport layer, session layer, presentation layer and the application layer, and what are the different protocols under the each of the transport layers, right? That also we are seeing, and in depth we again discussed about the DNS and the DSCP, right? So how the naming can be used instead of the IP addresses, right? So domain names service and the DSCP, that is dynamic host configuration protocol, how the IP address is can be assigned automatically to the end devices with the help of the DSCP and the DSCP pool services, right? So all these concepts we have studied in our last lecture, right? So uh, today we are going to start with our layer number 3, that is the network layer, right? And next lecture we will see about the first two layers, that is your physical layer and the data link layer, right? So in today's lecture we will see what do you mean by the network layers, right? The layer number 3, what are these characteristics, functionalities of this particular networking layers, right? In network layers, how IPv4 is important for addressing logical addressing part, right? What are the different header fields are there, right? What do you mean by source IP addresses, so destination addresses, right? What is the length of this particular headers, right? And what are the different fields that we will see. Then we will see the router, its functionality and the types of the routers, right? Because the router we will use as the intermediary devices at the network layer 3, right? So we will see about its function, what are the there are the different types of the routers. After that we will move forward to our what do you mean by the routed protocols, what do you mean by the routing protocols, right? Routed and routing protocols, and what are the different functionalities in between both, right? And what are the different protocols under each, right? That will also we will see with the help of some of the examples, right? And after that, what are the different types of the routing and the routing table, right? That is a very much important concept in with respect to your the network design lab, if you considered, right? So all these things we will see today. Okay, so let's start with the today's session with the first point, that is the network layer characteristics and functionalities, right? So if you consider if you see in this particular diagram, right, these are nothing but your the LAN which you see LAN cable, right, which having all these 7 layers which are shown, right, with each of the functionalities of each layers, if you see here, right? So in today's we are covering this network layer, which having the functionality, basic functionality is nothing but for your logical addressing and the path determination, right? You need to select a best path for your particular packets, right? That will be considered in your the network layer, right? How this path can be determined, right? How the logical addressing can be given to with the help of some intermediary devices, right? How the packet can be transferred in between the 2 or more networks, right, with the help of that devices, right? All these things we will discuss today. Okay, so network layer, for if you consider this particular OSI model 1 to 7 layer, right? So here the logical addressing can be done, right? So with the help of what, with the help of some IPv4 addressing, right? So there are two types here, IPv4 and the IPv6, right? These are the some communication protocol, we can call it as, right? So internet protocol version 4 and internet protocol version 6. Okay, so two communication protocols are there. And what is the functionality of this particular protocols? It will be just used to allowing devices to exchange data in between the networks, right, in between the devices, right? So what is the functionality of this particular network layer is gives you a 4 operation. Basically the first one is addressing the end devices, right? Whatever is your the end devices is, for example computer, laptop, right, IP phone if you are using, right, whatever the end devices are there, right, you need to give them a some logical address, right, which we can call it as an IP addresses, right? Then encapsulation is there, decapsulation is there, right, how the tunnel can be formed in between for sending the packet and all, right? Then routing is there, how you can send a packet from one network to another network, right, how you can route your information in between this communication thing, right? All these things is responsible under what, under your the network layer, right? Then we move towards first of all we will see IPv4 packet. It's already I think covered in your computer network pass, but I just brief it to you. In depth we will see in our later chapters, right? So in IPv4 the primary purpose is what it will be communication protocol, as you know already, right? It will be used, or it will be ensured the packet which will be the sent in the correct direction. It will be responsible for your the communication, right? Whatever the packet you are sending, it will be must be reached to your the destination, right? It must be received by the receiver, right? And then and it will be the handle the packets, right? So what are the fields of the header? So total these are nothing but one of for your IPv4 header fields, right? So here each of the field is of 4 bytes, right? So version is 4 bytes, the internet header is 4 bytes, the DS is nothing but your the again 4 bytes, sorry 8 bytes. Here total is 8 bytes and total length is also your, so total IPv4 is nothing but your 32-bit provides a logical addressing, right? So source IP address and destination IP address is very much important thing here, which will be again 32-bit. Header checksum is a 16-bit, right? It will be responsible for your error control and all that things, right? So if you see the total function, what are the total fields are there, right, and what are their description, right? So source IP address 32-bit, destination IP address is 32-bit, right? There are different protocols under this: ICMP, TCP, UDP, connection oriented, connectionless, right? Then time to live, it will be there, right? It will be useful for measure your the hop count, right? A header checksum, as I already told, is will be responsible for your error control and checksum part. And the DS is nothing but for the QoS parameters, right? As we know, the IP, it will be responsible for what you're to sending the packet from from the sender and receive towards at the receiver side, right? So this is nothing but the quality of service parameters, right? So this is nothing but your IPv4 parts. Then we will move towards our some intermediary devices, that is nothing but here the router is. It will be useful in your it is nothing but the layer 3 network layer devices, right, which will be useful for communication in between 2 or more different networks, right? It will be useful for sending the packets in between the different networks, right? It name is terms from the root, right? therefore it is called as an router, right? It will be find your the base path for the network, right? For example, the shortest distance in between for to send a packet from one network to another network, right? It will be find out the best shortest path, right? And accordingly it will be send the packets, right? And if for example, if the best path or whatever he has selected, right, that will be down, right? In that case, the different alternative path also can be find out by this particular in router networking devices, right? And if you consider the LAN, right, obviously the IP address of the router we are taking as a default gateway, right, for the all the end devices, right? For example, if you consider if you attach one end devices to this particular router, right, so for that particular end devices the default gateway is nothing but what, nothing but it's this router's IP address is nothing but the default gateway for that particular PC on that particular device, right? So all these points you need to consider for your network design lab also, right? In that also when we are designing new network, right, in that case also you need to configure some end devices with the help of this default gateway of this router, right? At the time you will come to know how it will be configured and how the default gateway can be assigned to the end devices with the help of this particular router, right? So what is the functionalities of router? As I told you, it is nothing but for sending a packet or receiving a packet from two different networks, right? If you consider this particular diagram also, right, so here there are some different network, and here is also one of the different network is there. If you can see the IP addresses, right, 10.120 it is a different network, and 172.16 it is also a different network, right? So in connection in between these two networks we are using some inter-networking devices, that is nothing but the router at layer 3, right? So it will be responsible for what? It will be responsible for inter-network communication, right? Also we have covered one topic, that is nothing but a reliable network, right? If you remember, in reliable network also we seen some of the parameters, the when you will call the network is reliable, right? The first part first point sorry, first parameter at that time we discussed, that is nothing but the fault tolerance, right? The how the network fault tolerance can be you will see in this particular network design diagram, right? So in this particular router there are some multiple paths are there, right? For this particular router, if you see, these are the this is nothing but first path, this second part, third part, and fourth way, right? So from these particular paths you need to find out the best suitable path for the packet transfer, right? So also that also manages by your router, right? So best path selection is also one of the function of your router, right? Inter-networking communication is also one of the function. Then packet switching and packet forwarding, that is also one of the function, right? To get a packet from this particular network and send it back to the different kind of a network, right? It is also one of the function of your routers, right? So in this particular diagram tells you all the functionalities of the router, right? From it will provides a inter-networking between the different networks, right? Then what are the types of the routers, right? So there are two types. The first one, obviously it is a fixed router, right? We can't upgrade it, right? Whatever is there in this particular router, okay? You cannot add, modify, delete, remove, okay? Whatever is there if for in this particular router, okay, does not have any of the slots, right? And also these ports are integrated with the motherboard itself, right? So that's why you cannot remove it or you cannot add something else in this particular router, right? It is nothing but the fixed router, right? While other one is your modular router, right? It can be it can be upgradable. You can add and remove the interfaces as also the ports, right? If you see in this particular diagram also, right, these ports or this interface part you can remove and you can add it, right? and a number of slots which will be depending upon the whatever the series of this particular router, right? So there are multiple series of the routers are available in the market. If you just Google, right, you will find out there are different plenty of the number of routers are there which having a number of series, right? And the series and each of the series is having a different number of slots, a different number of ports, different number of interfaces, right? So this is nothing but the modular router, right? Nowadays everyone is used modular router instead of the fixed router. Okay, then next one is here the router protocol, right? As we know that the in network layer the protocol is nothing but the IP protocol, that is internet protocol, right, which is nothing but the example of here the routed protocols, right, which will be useful for the logical addressing from the host to host based, right. It will be provide to send a packet forwarded from host to host based on the addressing scheme. Okay, so it is nothing but your the routed protocol, and the routed protocol is helpful, right. It will be support to provide the mechanism for sharing the routing information, right. What IP protocol do? IP protocol, it gives you the routing information, right. And the routing protocol, what routing protocol do? Routing protocol do, it will be messages or move between the routers, right. It will move between the routers, and it allows the routers to communicate with other routers to update and maintain the tables, right. So what routing protocols do? Actually, routing protocols, it sends a packets, right, from one router to another routers, right. It will be forwarded the information of routing protocols as well, right. It update and maintains the routing tables as well, right. And whatever the packet you are sending from one network to another, right, it can update their routing table information also, right. So this is nothing but the routing protocols functionalities, right. So what are the different routing protocol, right? So depending upon the functionality, again we are divided the routing protocols into a number of protocols, different protocols, right. For example, here some of the examples I have given. For example, RIP is there, IGRP is there, EIGRP is there, OSPF is there, and one more is BGP is there, right. Broader gateway protocol is there. So all these are nothing but the routing protocols examples, right. We will see this all these protocols, how to configure this routing protocol in the when designing any kind of a network, right, and what is the functionality of each of this particular routing protocol. Okay, we will see its demonstration as well in our network design labs, right. So you just keep in mind now what is mean by the routing protocols, and what is the functionality of it, and what are the different examples of this particular routing protocols, right. Yes, now okay, now in routing table, right. So if you when you want to check for from how the packet is transferred from one network to another, right, from which hop to which hop the packet is transferred, right, from which devices to devices it transferred, right. What is the IP addresses it follows, right. What is the source IP address, what is the destination IP address, right. What is from which interface it goes, while which interface it comes, right. What is the gateway address of this particular network, right. All this information, where you find all the information you can find in the routing table, right. So whenever the packet is transferred from one network to another network with the help of the router, right, the router can update its routing information, right. So from from what is the source IP address of that particular packet, and what is the destination IP address, through which gateway it can transfer, what is the net mask of that particular IP addresses, right. All this information you will find out in your routing table, right. So routing table is very much important with respect to our router, right? So here one simple diagram is there to clear the concept of what is routing exactly, right? For example, if you see here, the client is there and one server is there, right? In this particular two networking devices, we need to transfer, we need to send a packet, right? While sending a packet, we are using here the routers, right? So if you consider from this particular router, we are sending a packet to all this particular router. This particular router is sending a packet from this particular network to this particular network, right? So it is nothing but the inter networking devices, we can call it as, right? So here in terms of your reliable networks, we are not allowing here the fault tolerance and QoS parameters here, right? Because in fault tolerance, if you see, there are must be a multiple paths will be available, because if the one path is down, or it breaks, if some problem is happen, right, then it must be packet must be transferred to the another from the another path, right? So there is no any multiple paths are there, but still for the concept of the routing, understanding of the concept of the routing, we will see from one network to another network the packet can be transferred with the help of your routers, is nothing but your the routing, right? Then what are the functions of routing? Again, it is the process of moving packets from one network to another network, as we already seen, right? So it having a two functions, again determining the best path, right, which is the shortest path, which is the best path for your packet transferred, right? It can be determined by your router, right? Again and while after determining the path, you need to what, you need to send the packets, you need to forward your packets through this particular base path, right? And again one function is what, if this particular best path is down, right, then you need to find out the alternative path as well, right? And you need to send packet through that particular alternative path again, right? So this is nothing but your fault tolerance, right? If one path is break, that is nothing but your plan B. If plan A is not working, then you must be use your plan B, right? So this is nothing but the different functions of routing. Then we will see what are the different types of the routing we have, right? So I have listed here. So there are a total three types of the routing. The first one is your static routing, second one is dynamic, and third one is your default routing. So we will see one by one what you mean by static routing, dynamic routing, and default routing, right? If you consider here in this particular diagram, right, so total there are four routers are there, R1, R2, R3, and R4, right? And for example, I need to send a packet from R1 to R2, right? Now while sending a packet from R1 to R2, I must understand, or I must know the IP address, or the IP address or gateway address of this particular R2, that is in the router 2, right? If I know the IP address of this particular router R2, then and then only I am able to send a packet from this particular R1, because I know the destination, right? For example, if you want to send a mail, right, unless and until you not know the email address of the second person, how you can send the mail? You can't send, right? The same thing is here, right? So if you want to send a packet from R1 to R2, then there must be a one second sorry. So then there must be a you must know the IP address of this particular R2, right? And if you know the IP address of this particular R2, then what you need to do, you need to manually add it into the configuration of this particular R1, right? That is nothing but your static routing, right? So here in this scenario, you need to configure, maintain, and update by the network administrator manually. That means R2's IP address you need to manually enter into configuration of this particular R1, right? And then you need to send a packet from R1 to R2, right? Likewise, same thing is happened in this particular scenario, R2 and R4, right? So all this part you must know the destination IP address, right? And in order to know the and after knowing the IP address of the destination, you need to configure it into your routers, and then you need to send a packets, right? So whenever you for example, in this particular diagram, it is only a small scale network, right? It is very a small network, only a 3 to 4 routers are there, so it will be easy to remember the IP addresses of each and every routers, right? But what happen if you have the 50 to 60 routers, then how you can able to know or able to remember all these IP addresses and all, right? So it can't be possible, right? So for small network it can be possible to do a static routing, right, to configure IP address of destination to your network, and it is very a simplest network, right? If some redundant path is there, right, if some or again a different networks are connected to this particular routers, right, then it will be very difficult to understand the source routers to know the IP addresses of the each and every destination IP addresses, right, for sending a packet, right? So it is very tedious task, right? So it will be used, static routing, it will be used for very limited network, right? If you have only a small network, small scale network, right, 2 to 4 routers are there, then it will be fine, right? So here in this static router, everything you need to manually configure, right? You must know the destination IP addresses, right? All these things you need to keep in mind, right? So what is the disadvantage of it? It can't be useful for your larger large scale network, right? So in order to use large scale network, you need to use your second routing technique, that is nothing but your dynamic routing technique, right? So if we see in this particular diagram, in this particular network design, in this particular topology, right, so there are total 2 ISPs are there, right? ISP1 and ISP2. Okay, so here if you see, I have written here the routing protocols, which routing protocols are used by which network, right? So here ISPs are using the BGP, that is broader gateway protocol, right? Here ISP2 is also using the BGP, broader gateway protocol, right? All these are nothing but here the network. This is your first network, for example, second network, third network, fourth network, and fifth network, right? And each and every network is using a different routing protocols for sending a packets. If you consider first one, this is using your OSPF, right? This is again using OSPF. This is using your EIGRP protocol. This is again EIGRP version 2 protocol. This is RIP version 2 protocols, right? So all these are nothing but the routing protocols, right, which are connected together to this particular ISPs, right? And via this particular ISPs, these routers are connected, and from these routers there are some end devices are connected in between, right? So what dynamic routing do, right? It includes, for example, the first functionality is what? To discover the neighbors finding the best path, right? For example, this particular router needs to send a packet to these particular routers, that is router 2 of this particular network, right? So what are the different best path, right? So for example, the first path if you considered, then the packet will be transferred from this router to ISP1 to this particular router, and from this particular router it can be goes to R2. This is one way. Another way, from this particular router to ISP1, from ISP1 to ISP version 2, then this R3, then this R1, and then this R2, right? Then what is the functionality of dynamic routing? It can be useful for discover the neighboring best path, right? So it can be choose a best path, which one? This one directly, right? Because only a 2 hop is there, that is ISP1 and router 1, only 2 devices are connected in between this path. But while in this path, ISP1, ISP2, R3, R1, and then R2, right? So which one is the best path? The first path, right? So it can be managed, right? The second one is maintaining the up-to-date routing information. Obviously, when I am going to send a packet from this particular router to this particular router via this R1, right? So R1 has the information about this particular uh, source IP of this particular router, right? Again for R2, R2 is also having an information of this particular R1, right? So our routers task is what to update the routing information, right? Choose the base path which is available, right? And whenever the available base path is down, it must choose the second alternative path, right? For example, if you in this particular path there is this particular router one is down, for example, right, or for example this particular link is right, what happened, this particular router must go to the this particular way, the second path, right? This is nothing but the alternative path, right? So it is nothing but the your dynamic routing protocol. What? Why? Because it will be chooses a base path automatically, right? It will be update your routing information automatically, right? So all these tasks are done by your the dynamic routing concept, right? Now the what is the advantage then? It automatic updates the path, right? It changes the network topology or updates dynamically. Obviously the network topology is also dynamically updated, right? If you for example, if you scale your network, or you have added two routers again after designing the network, right, it will be update in your topology automatically, right? It routing information is also update automatically, right? So in this there are less administrative work. Why? Because in static routing, if you see, you need to manually configure the destination address into your routers configuration, right? So there are some administrative work is there, you need to kept in mind, remember the IP address of destination route, right? In this there is no need of such, right? The address can be automatically, it can be packet can be automatically sent to the base path, right? Then selecting the base path to the destination network we already discussed, and finding the second base path if base path is no longer available, that is nothing but the alternative path we already discussed, right? So all these are nothing but the dynamic routing advantages, right? So next one is the last one is your the default routing. Okay, so here a default route is a special type of a static route, right? Why? Because here you need to configure it manually. Okay, is used for the situation when the route from a source to destination is not known, right? When you not know the destination, right, or when it is unfeasible for the routing table to store sufficient information about the route. Okay, that can also be one possible thing, that where your routing table is not able to store any sufficient information about the route, right? In that case also you can use this default routing protocol, right? So we will see how all these routing protocols can be used, or can be configured with respect to our Cisco in a Cisco packet tracer, right? How to configure routers for two different networks, three different networks, right? How to choose a best path in between two routers, right? If one path is failed, how the path can be chosen by the router to send a packet from one network to another network, right? All these things we can do practically in our whenever the session will start, right? So this is all about today. So what we have studied today, we studied what do you mean by the network layer, layer number 3, what are the functionalities of it, characteristics of it, right? Logical addressing and the path determination is the function, right? Then there are some communication protocols are there, right? IPv4 and IPv6. In that 32-bit IPv4 format we have discussed different header fields are there. What is the IPv4 packet header format diagram we have seen: source address, destination address, checksum, right, version, protocols, and all that things. Then what is the router, right? Network devices, right? Its functionalities, types of the router, right? Fixed router and other router. Then next is your what is my routed. This is nothing but the IP, that is internet protocol at layer 3 network layer. then a routing function, and what are the routing different protocols, that is static routing, then dynamic routing, and then your default routing protocols, right? Types of routing and the routing tables also we have discussed. Okay, so this is all about today's lecture. There is a quiz time, so I will send you one link for this particular quiz, which having the 4 questions and the 3 minutes for you to solve this particular quiz. Okay, so it is mandatory for all the students to attempt this particular quiz. Okay, so I will just share you the link, you can just go through it. Okay, so that's it for the today's lecture. In next lecture we are going to see the remaining 2 layers, that is your physical layer and the data link layer, right? What are the functionalities of it, and what are the different medias and cables are there which will be useful for in this particular 2 layers, and what is the network intermediary devices also there with respect to these particular 2 layers. We will discuss this in our next lecture. Okay, so thank you for joining.